if the roots of b minus c x square plus c minus a x plus a minus c equal to 0 are equal. Find the relation between a, b, and c. This is a question. Try everyone. We started with a problem because every time we start with the theory. So why not? Yes. How far?
Sir, I'm not getting a relation, sir. I'm getting a equation.
What?
I don't know, sir, if it's correct. I'm checking it.
No. Tell what you have got. I can check that for you, right?
A square minus 4ab minus 4b square bc minus 6ac minus 3 c square. I don't know, sir. I can't simplify
That
it further.
that is not going to be working. How did you try it? What were the steps that you took?
Sir, I did d equals to 0.
Okay,
That's
got
it.
it.
Simple.
Fine. So property J, if a plus b plus c equal to 0, then one root is 1 and the other is c by a. Okay, apply that as b minus c plus c minus a plus a minus c equal to 0. Therefore, one of the roots must be 1. As the equation has equal roots, the other root is 1. Agree? That is why I gave you the properties. So what is the product of the roots? Product of roots.
Minus c by a, not c.
That first it will be 1, right? And that will be a minus c by b minus c. So this will be b minus c is equal to a minus c. Wait. Hey, b minus c minus a minus c. C by a, that is c a minus c by, wait. This will be b. Otherwise you cannot do this sum. Okay, then the discriminant method will also work. Okay, because this has to be circular, right? So b minus c minus a minus b. Now if you change it, it will work, because a minus b by b minus c, that's what it's supposed to be. That is why you are not getting it even if you are trying it in that way. Okay, so once you do this, you will get it correct. So b minus c is equal to a minus b. That that will give you what? 2b equal to a plus c.
Yes, sir.
That means a b c, oops, sorry, a b c are in ap. That is the relation. Now check if you can solve this using without the property. That should also work. Okay, the calculations will be a lot simpler. Okay, now that I have given you the correct value. Okay, it was supposed to be circular, you should have informed me. Okay, anyway, so since we have done this, let us move back to some theory. So what theory can we do next? All right, so let us learn the theory but with a problem. Try to solve this equation, x minus a. This one, sorry, 1. How will you solve this?
First taking the LCM and then
No.
transpose.
If you take the LCM, it will take the entirety of 2 hours to solve this one particular problem. Just look at what is missing in every part. Compare the numerator to the denominator. See what happens. I have placed exactly what you are supposed to get. See what happens in that case.
C, A, and
Yes, go on. That is the correct answer. So what will be the first solution of x?
C.
X equal to c. Why?
Uh, Y. Where Y?
Yeah, this will all go to 0, right? Because if I put x equal to c, this part will go to 0, this part will go to 0, and it will remain c minus a, c minus b. This will cancel up to be 1. So
Oh, okay, got it, sir.
x equal to c works. What are the other values?
B and A.
So x equal to b. Okay, basically x equal to a, b, and c, right?
Yes, sir.
Okay, fine. All of you agree? Any other roots here? If there are not any other roots, do you find any problem with the solution?
Sir, the highest degree, I guess it should be 2, no? So then how are we getting 3 roots?
Exactly. Yes, anyone? How can a quadratic equation have 3 roots? I just spent an entire day explaining to you how it cannot have more than 2. Fundamental theorem of algebra. So why is this an exception?
Sir, can all the 3 or either 2 of them be equal?
No. Even then, there are 3 distinct roots. A, B, and C are distinct, right?
Distinct.
Yes. A, B, and C are different.
Sir, can't they be same?
But can they be different?
Yes, sir.
So, if they can be different, then even if they are same, it wouldn't matter. There
Oh,
is a possibility that if A is equal to 1, B is equal to 2, and C is equal to 3, then we would get 1, 2, 3 as the solutions of a quadratic equation. How is this possible? Anyone? Any idea? This is possible because not being a quadratic equation. This is not a quadratic equation. This becomes an identity. Okay, so remember this. Whenever, let us write it down. Whenever a quadratic equation has more than 2 solutions, it becomes an identity. Okay, so if it is true for more than 2, it will become an identity. Very important, extremely important, and this question is asked many times here and there. Okay, you have to get the quadratic equations to at most 2 solutions. Quadratic equations will have 0, 1, or 2 solutions. Beyond that, if any solution is obtained, then the construct that you were solving was not an equation, it was an identity. And identities can have multiple solutions, irrespective of the degree that they are in. Okay. All right. Now that you know this part, we will go back to sum and product of roots. So sum and product, have we discussed it in detail? We have done. Now, how can we go from sum and product of roots to the quadratic equation itself? Does anyone remember? How can you go back? So if sum of roots equal to S, product of roots equal to P. So what is S and P? How do you calculate sum and product of roots? What is sum of roots of a quadratic equation? The standard quadratic equation ax squared plus bx plus c.
Negative p upon a.
Negative p upon
B
a.
by
What is p?
A
C by
C, C upon a.
C by a. Fine. So if sum of the roots and product of the roots are given, What is the original quadratic equation?
X square minus
X square minus
SX
sum of roots
plus
plus product
B.
of roots.
Very good. X square minus Sx plus P is equal to 0. Remember this. This will help in many problems. Okay. So what else can we do from this section? I don't think there is anything from here, but we can do a few problems. Okay. First one. If alpha if alpha is not equal to beta, alpha squared equal to 5 alpha minus 3, beta squared equal to 5 beta minus 3, find the quadratic equation whose roots are alpha by beta and beta by alpha. Try this. Let me double check if I've written this correctly. Correct. Fine. You know the formula, I just gave it, so you can use that. Yes, how far?
2 minutes,
Sure.
sir. Sir, it is coming in alpha beta.
Hey, how can the equation come in alpha beta? It has to be x and
So,
y.
means the coefficients.
What? How? No,
Mm,
no. Anyone else? Yes. Okay, you might have done the entire sum correctly, but you are missing something towards the end. Check. How will you get the value of alpha and beta?
We should be getting the value of alpha and beta.
No, you will get the value of the sum and products. Okay, alpha plus beta and alpha minus beta.
Yes,
These,
sir.
sorry, not alpha
Go.
minus beta, but alpha beta. You will be getting those two values.
Yes, sir. Yes.
Okay, so let us solve it. So what does it say? It says alpha square is equal to 5 alpha minus 3 and beta square is equal to 5 beta minus 3. This implies alpha and beta are solutions of x square minus 5x plus 3 equal to 0. Otherwise, how will you get these two relations? Okay. Now, alpha by beta plus beta by alpha is equal to S is equal to alpha beta by alpha plus beta. This is alpha square plus beta square, right? Minus 2 alpha beta. So, okay. Just before this, you will have to do one more step, right? And that step is from here, you can write alpha plus beta is equal to minus b by a. So 5 alpha beta is equal to 3. Okay, so this is 5 square minus 2 into 3 by 3. Calculate this, and then product will be equal to alpha by beta into beta by alpha, that is equal to 1. So from here, I think you can do it.
Yes, sir.
Finish it and tell me what you get.
I missed the second step, sir.
I know that is where people will miss. That is why the sum is given. There is a reason we have this sum here. Finish this. What is it? 25 minus 6 by 3. So this is 19 by 3. So quadratic equation, you cannot take this long to solve a problem. Quadratic equation is x square minus 19 by 3x plus 1 is equal to 0, which means 3x square minus 19x plus 3 is equal to 0. That will be your final answer. This step was also important. So these are the two steps that are important. Okay, clear?
Sir, could you please show the whole of the solution?
Hmm.
Thank you, sir.
Mhm. No problem. Okay, so formation of a quadratic equation is clear.
Yes, sir.
Would you like to do one more problem
Sure, sir. Sure.
or go for more theory? Okay, if I go for one more problem, then let us go for one more problem. It is said if alpha and beta are roots of 3x square plus 2x plus 1 is equal to 0. Find the equation whose roots are 1 minus alpha by 1 plus alpha and 1 minus beta by 1 plus beta. Try this one.
Sir, it is completed, but I am not pretty sure that it is correct or not.
Okay, tell me the answer.
X square minus 2x plus 3 equals 0.
Correct. Well done. Others, finish it. Okay, let me do it for the others. Otherwise, I don't think it is moving. So alpha plus beta from here minus 2 by 3, right? Minus b by a, and alpha beta is equal to 1. So sum of roots, that will be equal to just a bit of algebra, right? 1 by alpha plus 1 by beta, and then 1 minus alpha into 1 plus beta plus 1 plus alpha into 1 minus beta, right? That will be the sum of roots. So when you do this, what will you get? You will get 2 minus 2 alpha beta, and that will be divided by 1 plus alpha plus beta plus alpha beta, right? Put the values 2 minus 2. Okay, wait. Alpha beta is not 1. Alpha beta is 1 by 3, right? That's C by A. So here you will get 2 minus 2 by 3. Put the values. You will get 2 minus 2 by 3 and 1 minus 2 by 3 plus 1 by 3. So that will give you 2, right? 4 by 3 divided by 2 by 3. So then you have product. Product is 1 minus alpha into 1 minus beta divided by 1 plus alpha into 1 plus beta. So the denominator will be just the same, right? And the numerator will be 1 minus 2/3 plus 1/3. And the denominator will be 1 minus 2/3 plus 1/3, right? It is the same, just the interior part will be minus. So that would mean it is 3. So now you get S and P. So equation will be equal to x square minus 2x plus 3 equal to 0. Very innocent question, but very effective as well. Check, see if you have any doubts, and then we will move on to common roots. Okay. All right, next part. So two quadratic equations, ax square plus bx plus c is equal, ax square plus bx plus c is equal to 0, and a1x square plus b1x plus c equals to 0, provided a comma a1 is non-zero. If you want a common root to occur, and if you need the conditions for it, the conditions for it will be given by, let us write it down. It will be a1c, sorry, a1c, this looks like 9, a1c minus ac1 divided by ab1 minus a1b whole square for all of these is equal to bc1 minus b1c divided by ab1 minus a1b. This is the condition. Okay, this has to be true. You can get this by taking alpha as the common root and then solving both of the values of alpha using the cross multiplication method. Okay, that is where you will get it. Note it down.
Sir, I couldn't hear some parts. Sir, once again, can you say what this is for?
This is for common roots. The condition for two quadratic equations to have one common root.
Okay, sir.
Two equations have one common root if this happens. Now you all tell me what is the condition for getting two common roots. Both the root will be same. Then, . how will you get both the roots to be same? Array, try to imagine an equation where the roots are, let's say, 1 comma 2. So what will that equation be? X minus 1 into x minus 2. What will another equation be that has the same roots?
It has some other value of k except 1.
Yes, that's it. So if you have, okay, I hope you know this, everyone. So for any two roots, alpha and beta, quadratic equation is given by k into x minus alpha into x minus beta. Are all of you aware of this? So if this is the case, then k is a constant, right? Changing the value of k would not change the solutions of the quadratic equation, right? So that means for different values of proportion, you will get different equations, but the same roots in all cases. So both roots are common. This is the same condition as the infinite roots in the simultaneous equation. So there, a by a1 is equal to b by b1 is equal to c by c1. Okay, if all of them are proportional, then all the roots are equal. Okay, clear?
Sir, can you explain this twice?
Okay, so when you have a equation that has two roots alpha and beta, then you can just multiply those as factors and get back the quadratic equation, right? So if you can do that, if you can multiply the factors and get back the quadratic equation, you can also multiply it by a factor k. Since how do you solve the quadratic equation? We set this to 0 and we get x equal to alpha and beta. This k, if it is greater than 0, or does not matter, if k is a constant, it will get cancelled here anyway, unless k is non-zero. Okay, then this will work. So what does this mean? If let's say we have alpha and beta equal to 1. Okay, so x squared minus 2x plus 1, that is the quadratic equation. If I multiply it by 2, I'll get 2x squared minus 4x plus 2. This is a different quadratic equation than this, but both of them have the root 1 comma 1, right? So both roots are common. That will only work if all of the coefficients are in proportion.
Got it, sir. Got it. Thanks.
Okay, okay, fine. So what else is there? Okay, we will do graphs next day. Today let us do a few more sums.
Sir, I have one doubt, sir. How did we derive these formulas? Like, can we derive it?
Which one? This one?
Yes, sir.
This one you can just put x equal to alpha. Okay, because if it is a common root, you can just assume that x will be equal to alpha. Okay, then you can solve this like simultaneous equations using the cross multiplication method. Okay, that was in class 10 ICSE, method of cross multiplication. If you apply that, you will see that this is the exact solution. Okay,
sir. Yes.
But this is rarely required. The derivation is rarely required. You just need the application of it. Okay. All right. Next problem. So if ax square plus bx plus c equal to 0 and x square plus 2x plus 3 equals to 0 has a common root. Find a is to b is to c. Try. That is the sum. Yes, this is not a difficult problem. How are you approaching this?
Using the above formulas.
No. See, if I give you a question right after a formula, just think a little. How does this equation look? Discriminant. Discriminant is b square minus 4ac, right?
Sir, is the answer is 1 is to 2 is to 3?
Yes. So if discriminant is b square minus 4ac, here it is. Let us not write b square minus 4ac. Let us just write 2 square minus 4 into 3 into 1, which is less than 0, implies complex roots. So two complex roots. That means in conjugate pairs. Right? That means implies both roots are common. Therefore, it will be in the same proportion. So you will have a by 1 is equal to b by 2 is equal to c by 3. Implies a is to b is to c is equal to 1 is to 2 is to 3. If I give you a formula, do not just blindly start following that same formula. Okay. Of course, I will not give you a problem that directly leads to it. Or I may give. Surprise. Okay. Clear?
Yes, sir.
Okay. Uh, Next. If these sums are different from your normal board exam problems, right? If A, B, and C are in GP, then ax square plus bx plus c equals to 0 and dx square plus ex plus f equal to 0 have a common root. Okay, then show, this is a subjective question, show that d by a, e by b, and f by c are in AP. Try this. Yes. How would you do this? What is given? These are in GP, right? So if they are in GP, then B square will be equal to AC, which means I can just write B equal to root AC. So the equation becomes AX square plus root AC x plus C is equal to 0. Right? What happens then? I see. I made a mistake in the sum again. This was 2bx. Okay, so if it is 2bx, then it will work. Okay, so 2bx means here you get 2. So when you replace this, you get root over a plus root over c whole square is equal to 0. There is x somewhere. Wait, root over a x plus c is equal to 0 whole square. So that means this has repeated roots and x is equal to plus minus root over c by a, right? Plus minus root over c by a. Well, this is a common root, right? So if this happens, well, this is equal to 0. That means it will be minus, just minus. Okay, repeated root and equal root. So this will just be minus root c by a. Now, if there is only one root, then this is the common root. So minus root c by a is the common root. All right. Once you have this, I think you can finish it from here. Try. You just, if you have the common root, you can just put it in the next equation and that should give you the answer. Right? See if you get it.
Sir, why aren't we writing b equals to plus or minus root a
Because it is
whole
0,
square?
right? If you take the square root on both sides, you will get plus or minus 0. The plus or minus 0 is the same thing, right? Just because it is 0, that is why we are doing this. Okay? All of you understood, right?
Yes, sir. Yes, sir.
Okay, because if I take root here, root there, it will be plus minus 0. Plus minus 0 is just 0. So what happens if you put that in? You will get d into c by a minus e into root c by a plus f is equal to 0. Agree?
Yes, sir.
So you can just put that on the right hand side. So you will basically get, I think you can cancel, you can divide by c throughout. Well, okay, first of all, you can write d into c by a plus f, sorry, d into c by a plus f, that is equal to e into root over c by a, right? So if I multiply by c, what would I get? Okay, so there was a 2 here as well. It should have been 2ex. So that is where the 2 will come from. So you have a 2 here, you have a 2 here. Okay, so how will you get rid of this? You can take the whole square and so on, but I think you can finish it from here. Try. See what happens. You can just write the whole square, right? So if you divide by C, you will get D by A plus F by C is equals to 2E divided by 1 by root AC. You don't need to square it. You can just replace this by B because B is equal to root AC. So you will get D by A plus F by C is equal to 2 of E by B. That means AP. Arithmetic means. All right. So these type of problems are a bit tricky just because. Okay. First of all, I give you the wrong problem. Apart from that, also these problems are a bit tricky because you have to realize that whenever you get a root, there are no copies of it. And if we look into the common roots, then of course this is going to be the root that is common in both the equations. All right. Now in the next class, we will learn about the graphs of a quadratic equation. Extremely important. And I will be using